And with this being said, I guess we can start.
Yeah, I'm just gonna take a sip of water.
Of course, go ahead. So my name is Eva. I'm an account manager here at SciNote, and I'm very excited to be here with Arun today because this is our second live in-office webinar, and it's actually the continuation of the first one that we did last year or so, which was also on inventories. And today we would like to give you something more. In fact, we will not only cover, let's say, give you an overview of the SciNote inventories. We will also show you some examples of the most common inventories that you can set up in SciNote. But what we will also do, we will also put everything together because in the meantime, we also set up our company.
Hypothetical company for this webinar.
Exactly. So we want to show you how you can put everything together, starting from SciNote structure, a workflow, protocols, and then how you connect it to our inventories.
Yeah.
Yeah. Word to you, Arun.
Yeah, thank you, Eva. Like Eva said, my name is Arun. I'm a solutions engineer at SciNote, so I work closely with Eva and also a lot of our customers. And like Eva said, the previous webinar we did on inventories was about, I think, almost 2 years ago. So we've added quite a few new things to the inventories. And we're pretty excited not just to show you what they look like in SciNote, but how you would use these features as a part of your workflow in the labs. And hopefully this triggers some ideas, inspires some new ways you can use the SciNote inventories. And of course, any questions, please put them in a Q&A. Or if you want to save questions for later, you can always email our support team, meet with your customer success manager, review the webinar recording, and see how you can even set one of these inventories up for yourself. And with that being said, let me share my screen. All right, so we're gonna jump right in, and we'll actually start with the inventories since the focus of this webinar is inventories. A couple of high-level points about the inventories. First and foremost, there is no limit on the number of inventories you can create in SciNote. You can create as many inventories as you'd like. Once you're done using an inventory, you don't have to delete it. You can just simply move it to the archived state here. It will preserve all of your data, including the traceability information. So putting it in the archive state is always nice because it doesn't clutter up your active workspace, but it also retains all the information, keeps it accessible to you. And if you ever want to bring back that inventory and use it, you can always move it from archived back to active. And this also applies to the number of items in the inventories. No limit on the number of items in each inventory. But of course, as you're consuming items and they're fully used, or as an item expires, you can always archive it from that inventory. It just, again, moves it to the archive section, doesn't delete the item itself or any of the associated information to it. Now, before we jump into some of the examples, a general note about the inventories. They are very, very customizable, quite flexible in how you can set them up. And this allows the inventories to be used for a wide variety of use cases or applications. The 5 inventories I've created for today are just the most commonly used use cases that we see based on talking to our customers. But of course, you can get a lot more creative with the inventories. And before we open up some of these inventories and get into it, I do want to highlight something quite new that our product team has introduced, which is when you're building a new inventory, you can leverage some of these inventory templates that we've pre-configured for you. So if you select a template and create a new inventory with this template, a lot of the columns are already populated for you, and the column types, the data formats, are already configured. You can then adjust it from there by removing some columns, adding extra columns. So really, it's a good foundation to start on. And if you want an idea of what columns are included in each of these templates, just go to these information icon here and it'll show you all the different columns that are included, as well as the column type here. In fact, when I created these inventories not that long ago, I did use the inventory templates as a foundation and then made my own modifications to it based on what I needed. All right, so now we'll dive into some of these inventories here. The first one we'll start with is a sample inventory. For our example today, I went with a next-gen sequencing sample inventory just because that's where my previous experience was in. So I'm a bit more comfortable with that subject area, but really this could be cell lines, any other samples. For today, we're going to focus just on this specific example. And opening this inventory, we have a few columns here, and in your SciNote inventory, the first three columns, the assigned column, item ID, and the name column, are really the only default columns that need to be present in every inventory. All these other columns that you see to the right are ones that I've created myself, so you can add additional columns, rename the columns, as well as configure what type of data is going into each column. When I say what type of data in each column, well, let's take a look at that. So when I edit this item here, you'll notice the name column is a text field where you can basically input information directly into that field. Whereas the sample type column is one with a set of drop-down options that are pre-configured. So you'll pick one of the pre-configured options for you. You don't have the ability to enter any information here. Same with the date column, you're picking a date. And when you're using this column type, you can actually set reminders. And we'll take a look at this when we look at reagents and instruments. And then again, the concentration column is a text column because you can input any sort of information in here. It's not pre-configured. It's going to be unique every time. And then the documentation column, this one is set up to be able to upload files into. So in this example, with my NGS sample inventory, I'm receiving patient blood samples. So obviously there's a patient consent form that is associated to it. I've decided to upload it to my inventory so I can keep track of the patient sample, the consent form, as well as all the associated data that I generate using this one patient sample here. And one more thing I'd like to highlight in this specific inventory before we move on is this relationships column here. So we have a feature set in the inventory called item relationships. This allows you to pick one or more items and draw a hierarchical relationship between those items. So in this example, we have a patient whole blood sample that we receive. And then in our hypothetical company, what we're doing next is we're extracting the DNA from this whole blood. So we can see here the second item here, it says genomic DNA. And then this genomic DNA item, we need to know where it came from. So it's linked to the parent item in this case, which is the whole blood sample. And that can be visualized here. So in the relationships column, you'll see two numbers. Number on the left indicates if this item has a parent item, if so, how many. Number on the right indicates if it has a child item, and if so, how many. So let's say we're taking a look at our genomic DNA. We want to know which patient whole blood sample did this come from. I can click this number here, brings up the item card, and under the relationship section, I can see that the item that's the parent item is patient 001-blood. And if I wanted to know more information about this specific item, I can just click on this here, and the item card will update to give me information about that parent item here. Now, an important note to make here is when you want to establish these item relationships, the items do not have to be in the same inventory. Now, if I wanted to, I could have a separate inventory for all patient whole blood samples, a separate inventory for all the genomic DNA samples, a separate inventory for all the libraries that I generate, and then a final inventory for pooling all the library batches that I've generated here. So again, it's flexible. It's up to you how you want to batch or categorize your samples when it comes to putting it in an inventory. And despite items being present across two different inventories, you can still use the item relationships function and draw relationships between items present in different inventories. All right, so we will go back to our inventories, and now we're going to take a look at the reagent inventory here. So again, very similar approach, except you'll notice the column headers are different, and some of the data that I'm capturing is also different here. So here I have the most commonly used reagents in our lab at our hypothetical company here. And I'm tracking information such as what type of reagent this is, which vendor it's coming from, the catalog number, so I can reorder this very easily. The lot number, which is important to keep track of because the data that we are generating when we're doing verification and validation is controlled under compliance. So lot number tracking is important. And we also want to track the expiration date because, of course, we don't want to generate any data using expired reagents. And this is something I alluded to earlier, which is when you're using the column type date. So when you're using this column type that allows you to pick a date, you can set up reminders. And in fact, we do have a reminder being flagged here. So we can see this red warning dot under the date, as well as this alert bell. And if I click the alert, it's telling me that the item is expiring in 5 days. I should definitely be replacing this item soon. And once the item has expired, this alert will update to tell you that the item has expired. And with the date reminders, you can enable email notifications so that you would get an email notification once the item is getting close to expiring or once the item has expired. So that way you don't always have to log into SciNote to check this information. Once you see the email notification, you can take the appropriate action and reorder more reagents or restock the reagents as needed. And then I'm also tracking the stock of the reagents as well. This is important because, and you'll see this in a few moments later during this webinar, when we're actually using these items in a protocol, it's important to keep track of how much is being consumed. And you can do that with the stock column here, because as you input how much you're consuming at the protocol level, the inventory is going to update to reflect how much is left. And beyond that, we also give you the ability to configure low stock reminders. So we'll see here, you can enable the low stock reminder. You can define the threshold of low stock for each item. And now in the protocol, as you're inputting and consuming certain amounts, the inventory is updating to reflect how much is left. In this case, once the remaining stock enters 50 microliters or less, the low stock warning is going to trigger. So you will see a warning in SciNote, as well as an email notification informing you that you're running low on stock. And then for your reagents, if you wanted to keep track of the safety data sheets, you can. So you can upload those safety data sheets for each of these items. And then also the price per unit. So if your lab or your company is interested in keeping track of how much is this project costing me in terms of reagents or consumables, well, if you have the price per unit captured in your inventory and you're using the stock column, you can select a handful of items, you can export the consumption report, and this will give you how much was consumed in each project, and you multiply that by the price per unit, and you get a total cost in the end. And this is something I will show you towards the end of the webinar. We will export a consumption report, and I'll show you what it looks like in Excel. All right, the next inventory we'll look at is consumables. Now, this is going to be quite similar to the reagent inventory. You can choose to have a reagents and consumables inventory or split them up. Again, the flexibility is there. Depends on whatever is most conducive to your use case and your workflow in the lab here. For my consumables, I'm tracking again the manufacturer, the lot number, the catalog number, when they expire. and the stock as well, because I want to be proactive when it comes to restocking the supplies and reagents in my lab. So I'm going to use our track the stock, configure low stock reminders, so that once the low stock warning triggers, I'll go and reorder what I need and restock the lab for my scientists. And the next one is to manage your lab equipment. This one is actually quite common and quite important as well, because you may have different instruments in your lab, and managing all of this in SciNote allows you to track what instruments are being used in which protocols. So once you generate some data, if you want to understand which reagents were used, which instruments were used, all of that can be extracted from SciNote very easily if you're managing all this information in SciNote. So for my instruments, I'm primarily interested in managing the availability. So, we're a very resource limited lab, but all of our scientists are fighting for using the instruments. So being able to track this information in a central location like SciNote, where all the scientists have access, makes it a lot easier for planning out experiments, because they can see which instrument is available, and if it's reserved, how long it's reserved until. And this is actually can be tracked here with a separate column. So you can add a reserved until column and update that as you're reserving and using the instrument. And also, more importantly, for my inventory here, let me just expand this column so we can see it a bit more clearly. Sorry, my mouse is a bit tricky. But the calibration dates. So depending on the instruments, they all have to be calibrated at different intervals. And it's important for you to plan ahead and know when the next calibration is due, in case you have to call in the service tech or do the calibration yourself. That does imply some downtime for the instrument, which means the scientists in the lab are not going to be able to use it. So tracking the calibration date here and making it visible to everyone using SciNote can be quite effective, again, when it comes to planning out experiments, as well as when they're about to use an instrument. You don't want to accidentally use an instrument that's out of calibration, because that invalidates the data being generated by that particular instrument. And then all these other columns here, again, depending on how much you want to track, you can have the manufacturer, the specific model, serial number. You can even upload a troubleshooting guide, user manual. All this information can all be captured in the inventory right here in SciNote. And maybe one more piece of information I'll touch on before we jump to the next inventory is the traceability aspect. So if we look at this assigned column here, you'll see different numbers for the 3 different instruments. These numbers indicate how many different protocols has this item, in this case, instrument, been used in. So both these instruments have been used in one protocol in SciNote, and if I want to know which one, I can just click on the number. It will tell me exactly the name of the protocol, name of the experiment, and name of the project as well. As this item is being used in more projects, more protocols, this number will continually increase. And when you click on it, down here, this little pop-out will be bigger, and you'll see all the different protocols across multiple projects where this instrument is being used. So again, this applies to all items. So same with your reagents, same with your samples, same with your consumables, or really any other items that you're tracking. And then this last inventory I have here is not as common, but it's quite useful. And based on some feedback we've gotten, some of our customers really do like tracking this information here. This is to track the resources you have in your lab. Now, whether you're doing internal product development and you want to track how much a project is costing you in terms of resource hours, you can use it for that. Maybe you're doing services for external clients, and depending on the statement of work that you sign with them, there's only a certain number of hours of work that each resource is committed to for that particular client. So if you want to track it to that degree, you could have separate inventories for each client and track how many statement of hours or statement of work hours they have left for that particular client. And then, of course, you can track their role, the department, and to track the number of hours, we're using the stock column. And you can also export this data and track it across multiple different projects, because when you're using the stock column, you can export that consumption report, which will give you this information. All right, so now we've looked at a few different inventories. Before we jump to the next sections, two things I wanted to highlight here is if you're setting up a new inventory, you can use this import items functionality here. This allows you to set up your inventory in Excel and just do an import, which will import all the data from Excel into SciNote. So that's one use case for this import function. The second one is if you have an existing inventory, let's say you have 200 items in your inventory, and you're interested in updating one column across 100 items. Well, you don't want to be in SciNote clicking edit and updating this 100 different times. What you're going to do is, in that case, is a bulk update. And for that, you can essentially export this entire inventory as an Excel file. In Excel, you can do that bulk update across those 100 items. It's a lot easier to do in Excel. Once you've made that update, you basically re-import that file with the updated data points, and SciNote will only update the inventory fields that you've updated in the Excel file. So this is a great way to make bulk updates across your inventories in SciNote.
Yeah.
And I guess the last thing I forgot to mention is a search function. So the each inventory has a search function. So if you have 100, 200 items, this search function is very specific to just the inventory you have open. So it's a lot easier to search within the inventory using the inventory search. We do have a global search, which can also search across all the inventories. But if you're very sure that an item you're looking for is in this inventory, it is faster and easier to use the inventory specific search. All right. Sorry, before we go into the project use case, there is the item locations, which is a bit of an inventory adjacent feature. So this is particularly useful if you're interested in tracking the exact locations of samples, reagents, instruments. And we see this being used a lot for things like cell lines, genomic DNA, patient blood samples, things where your quantity is quite low and very precious. It's important to know exactly where those samples are, especially if people are sharing these items and things are being moved around. So with the locations feature here, you can create as many nested locations as you want. So for example, I have a freezer, and if I open the freezer, I've got 2 shelves in that freezer. If I open the shelf, I can see I have 3 different boxes in this shelf in this freezer. If I open each of these boxes, I can see in the exact box position what item is there. So let's take a look at our genomic DNA samples. Oh, nothing in here. Maybe I opened the wrong one. Let me take a look.
Yeah, in the meantime, I just wanted to say that I have many customers who use the import feature in the inventory to edit in bulk. And that's very useful and saves a lot of time. So
Yeah, my apologies earlier. For the other boxes, we'll be assigning positions from the protocol as we're using those items in our experimental workflow. So we'll take a look at that. What I already do have assigned is the whole blood sample from the patient, so that you can see is assigned in position A1. Similarly, as you get more samples, you can assign them to A2, A3. And even for assigning the locations, you can import data from Excel, because it's a lot easier to assign locations in Excel rather than clicking each position one by one and then saying, okay, which item going here, selecting the inventory, selecting the item. Now, if you have a limited number of items, you can very easily do it this way. But if you're dealing with 20, 30 items, it's a lot easier to use the import function here. And from the location section, you'll see which, in this case, which refrigerator, which shelf, and in the shelf, which box, and in the box, which position. You see the item ID, you see the item name, you see how much stock you have left, and you see any alerts if it has expired or if it's low stock or if the stock has been fully consumed. And that's important because if the stock has been fully consumed or if it's expired, you don't want to keep this in the box. You basically remove it from the box and then you can unassign the location from here as well, freeing up that space to be used by a new item that you're going to store in that particular box. All right, so now that we've talked about the inventories, the different use cases for the inventories, let's put this all together in an actual workflow that you might run in one of your labs here. So for today, Ava and I decided to have a little fun with it, which is what we referred to earlier. We created our own hypothetical company here called Pineapple Diagnostics. And today, Pineapple Diagnostics is doing a validation run of one of our assays. So we have the panel-seq validation run here. So this is the project, which I'm going to open. And in this project, this is the workflow that we're going to be doing. Basically, receiving the patient blood, doing some sample accessioning, so logging the sample information, and then extracting the DNA from that sample, taking that extracted DNA and preparing a library of that DNA, so amplifying that DNA and prepping the library. So we'll take a look at our workflow. And so these are the individual protocols in this experiment. And we're going to go through each one of these because I want to show you how you can bring in your inventory data, how you can create new items, how you can create relationships, all of that from your protocol. So you don't have to keep switching back and forth between the inventory and the protocol section. Everything can be done in real time as you're running this protocol in the lab. So we'll start with the sample accessioning here. So first, let's take a look at our protocol. So it tells us what we're doing. So we're logging the incoming sample, assigning a unique ID, uploading the patient consent form, any other intake documentation, and then placing this sample in a designated storage location. So first step, inspect the sample. Let's assume we've completed that. And then next, we want to assign a unique ID. So first thing we want to do is take the whole blood patient sample, assign it to this item. So I'm going to go to my sample inventory, and we're working with patient 003, the whole blood sample. We can check that it's whole blood, the collection date, how much volume, and I haven't uploaded the patient consent form, but ideally it would already be uploaded. So you can check all this information and then confirm that, all right, we're assigning this to this particular task here. So now from the sample inventory, we can see the sample name that's been assigned. And then now we're going to be assigning a unique ID. So the sample unique ID for this one is going to be, we're just going to copy it from here. Sample type, whole blood, collection date could be today. Staff assignment is me. And I'm going to submit this form. And this is our forms feature, which I'm not going to spend time on today because it's not the focus. But it's a great feature to use, especially when you're capturing or logging information such as this one, because it's very controlled, it's restricted. You can set it up so that once the form is filled out, it can no longer be edited. And then you can export all of the data entered into this one form into an Excel file. And lastly, we have those last two steps where we're going to upload the documentation and assign a location. So first, let's assign the location for this sample, and I can do that directly from here. So I can click on the sample. It brings up the item card. I'm going to quickly navigate to the location section and just assign a new location. I know this one is going to go into the refrigerator, in the shelf, in the whole blood box. And SciNote will automatically identify the next free space and pre-populate that. If you're intent on placing this in a very specific location, you can update this information, but SciNote automatically identifies the next available free spot in the box. And we're going to go ahead and assign this there. And then let me just make sure I've completed all my protocol steps. And then in an ideal situation, you would update the task status to in progress, completed. And if you wanted someone to review this information and sign off on it, you can push it to in review, send it out for signatures, etc. In the interest of time, we're not going to go through all of that. We're going to jump to the next step here. So the sample has been received, has been logged. Next, let's extract the DNA from the sample. All right, first thing, we know what sample we're using here to extract the DNA. So we're going to go ahead and assign that sample. We're working with patient 003, whole blood again. And then our first step here is to review the materials. So here we know what the output is going to be. It's going to be genomic DNA. The sample being used is patient 003, so I can update this right here. And then these are the other reagents we're going to be using. We're using some lysis buffer, a sterile filter unit, biosafety cabinet, and we know which lab associate is going to be doing this particular extraction procedure and how much time they should be consuming for this particular procedure here. So let's go ahead and assign these items. So first thing is consumables. We're using the sterile filter. And then let's check our reagents. So we're using the lysis buffer here. And once again, before you decide to use the reagents, you can again review the lot number, expiration date, how much stock you have left. In case the item is 1 day away from expiring or has expired, maybe we reconsider using that one and pick one from a different lot. Or if we're very low on stock and we know that we don't have enough stock, then we don't want to begin this protocol with this particular lot of the item. So we'll assign this. And I think all that's left are the resource and equipment. Okay. This one is just biosafety cabinet. And the resource is going to be our lab associate here. Okay, so materials, check. And then we're going to review the protocol. And let's say we performed and completed this protocol here. We're next going to want to fill out the form for the genomic DNA that we extracted. So for this one, we do have a preferred naming convention that's specified here. So I'm going to copy the standardized nomenclature and just update this to patient 3. We know the parent sample was whole blood, so I can update that as well. And the concentration, as a part of the protocol, you would have measured the concentration at some point. The specific number isn't important. I'm just going to make something up. Same with the volume. I'll just make something up for now. And then we're going to submit this form. So that step is complete. And then we have to make sure we assign a location to where this item is going to be located, as well as establish this hierarchical relationship, because we took the whole blood sample, we pulled out the genomic DNA. So in case down the road, we get some results post bioinformatics analysis, and we want to know which patient did this come from, we have this item relationship tree that will tell you which patient that specific data set was generated from. So a couple things to do here. So first, let's assign, well, actually, I went a few steps ahead. First, we're going to have to create this item because we just extracted the DNA. We haven't logged it into the inventory yet, which is why we have this create item function here. So create item, we know it's going to go into this inventory. We know the item name. And we can mark this as an output because it'll tag that item here as an output. So when you generate a report for this particular experiment, in the report, in the inventory section, it'll show us that in this specific protocol, patient 003 genomic DNA was an output of the procedure. So item has been created. If I expand the inventory here, genomic DNA flagged as an output. So this is what you would see in the report when it's generated. You would see that this is an output of this protocol here. And then, of course, we have to establish the relationship. So I'm going to add the parent. I know it was patient 003. And then let's go ahead and assign the location as well. So now, since this is genomic DNA, it needs to go in the freezer. And we'll put it in the genomic DNA box here. All right, so now let me just double check everything. Yep, so quantified, location assigned, relationship established. And then of course you would again update the task status as needed, but I will go ahead and jump over to the final protocol of this workflow, which is preparing the library from the genomic DNA that we just extracted here. So we'll do a quick review of the protocol. So here, we're basically building the indexed sequencing library from the genomic DNA we just extracted. The specific procedure here in this protocol is a tagmentation-based one, and then we're going to be recording the output volume, concentration, and then creating a new inventory item for the library that we generate based on this genomic DNA that we extracted from patient 003's whole blood. So first step here is the actual protocol. Pretend that we completed this protocol here, marked it as complete. And then now we have to fill out the form. And I'm going to copy the naming convention specified here. So we know this is 003. We know this came from patient 003 genomic DNA. Volume, I will make something up, and concentration, same thing. I'll just make something up for now. So data has been captured and logged. You can submit the form. And then we have a few steps here. We have to update the sample inventory. So first thing we need to do is create the item itself. So we're going to go up here, create the item. We know which inventory we're logging this in. The item name is going to be patient 003, library A, and I'm going to mark this as an output. And then we want to, let's refer back to our checklist actually. So first, set up the item relationship. So we know which item this library was generated from. So we know it's from patient 003, but in this case, we used the genomic DNA and established the parent relationship. So relationship done. We can update the concentration as well. So concentration was 230. So let me bring up the item card again. So from here, we can update the concentration column, and we can actually update all this other information as well. So we know this is an index library. We know the collection date is today. Concentration, volume. And then if you wanted to upload any documentation, you can. We set up the relationship, and then now we're going to assign the location for this. So again, since this is a index library based on genomic DNA, it has to go in the freezer, but we have a dedicated box for all the indexed libraries. And since it's an empty box, it's going to automatically pick column A1. Let's assign that. And I think that should cover our checklist items. Yeah. Concentration check, volume check, location check. And then in this case, I did put the materials at the end, mostly just to show you that there's different approaches you can take. You could have the materials at the very beginning and then assign all the items before you begin the protocol. Some teams might prefer to do this at the end. So again, the flexibility is there depending on how you want your workflow to happen in a particular sequence. But we're going to go ahead and assign some of these items as well. So the first thing is which genomic DNA that we use. This should be patient 003. It's my mistake. So we'll go back to our inventories. Assuming we had a lot of items, I would just search for 003. And then we had the tagmentation enzyme, master mix. Okay. So we have the tagmentation enzyme and the master mix. Let's assign that. And while we're here, let me also update how much we're consuming. So 5 microliters and 15. So we can input that right here. 5 microliters. Notice how the remaining stock updates automatically. Same for the master mix. Remaining stock will automatically update. If we moved back to the inventory, we would notice that the inventory reflects the updated amount here. And the last couple of ones, so we have the PCR plate, adhesive seal, thermocycler, and our molecular technologist. So let me update that. So equipment used, thermocycler. And since we are using this instrument, I would update this to in use. And then if you had a column here for reserved until and who reserved it, you can update those columns in real time as well. And then I believe the last couple ones, consoles, is just the PCR plate, adhesive seal. Assign those. Consume one of each in this case. And the last one we have is our resource. For this one is our molecular technologist. And we're also going to consume. This one's a bit longer, so 3 hours of our text time here. So 3 hours. All right, so let me collapse the assigned items. Do a check here. So we completed that. Updated the inventory. Assigned the materials. Done. And now, ideally, we would update this from not started to in progress to completed, send it out for review, signed off, close out this particular workflow. And once this particular project is complete, you can generate a report for this entire workflow. It would contain all the information that we at some point discussed today. So we'd have the name of the experiments, name of the protocol steps, what items were used in each protocol, how much of those items were used in each protocol, where we placed them if we assigned a location, which items they're related to in what capacity, since we established the relationships for new items that we created. We created some items, marked them as outputs, and we basically closed out this workflow here. Now, as we're getting close to time, I'm going to check with Ava if there's any specific questions.
So first of all, thank you for the presentation, Arun. I think it was great to see how we can put everything together for our hypothetical company, which we didn't tell you the name probably, but we.
Oh yeah, well, we named it Pineapple Diagnostics.
Exactly. So if you want to know more about how we are running it, you
Please
can
reach
just
out to us.
Yeah. So before we go through the questions in the Q&A box, and if you haven't already, please make sure that you type them there so we can answer them live. Maybe as the co-founder of the company, I would like to know how much did all this cost?
Yeah, I dread that question, Ava, and I know you're the more responsible one, so let me get this information for you. So the way I'm going to compile this information, I talked about it earlier briefly. So the most costly reagents are going to be, in this case, let's assume it's our master mix and our segmentation enzyme mix in this case. But in reality, it's probably going to be our probe and some other stuff. But for today's example, let's assume it's these two. Since when we set up this inventory, we did track the price per unit. So I can export the consumption report, which will show me in every project how much of these reagents were used. And depending on the specific project that we're doing the cost of goods analysis for, we can filter for that project, do a sum of the amount of that reagent that was used in the project, and multiply it by the cost per unit. So let me share my screen for the Excel files that I
love
exported.
that I can do everything on SciNote, of course.
Yeah, and you have a SciNote license too, so you can come in and take a look at if I'm being financially responsible or not. But let me just move my screen share to show you the two Excel files. So just give me a moment here. Where's Zoom? I'll just share my entire screen. Okay, so I exported two things. First, I exported the consumption report, and then I also exported the general inventory. So what I mean by that is I just picked the two items that I am interested in. And under export, there's consumption and there's items. Export consumption will give you the consumption report. Export items will compile all this information here, so all the column data, into an Excel file. So the reason I exported the column data is because I need this price per unit information. So if we jump back here, so here I have my price per unit. So I'm just going to copy that, go to my consumption report, which looks like this. Actually, it's easier if I just copy the consumed amounts. So let me do it in reverse. So I know the consumed amounts. Go here. Ooh. So we know the item name, ID, consumed amount. And then now we want total cost. So all is take the consumed amount times the total cost. And then I can give Ava her total. of how much we spent on this little exercise. So 475 hypothetical dollars.
Okay, we are within
Within budget?
within budget, yeah.
Great. So I haven't bankrupted the company, have I?
Not yet.
Not yet, of course.
All right, let me see if we have any question here. So we have a question regarding the possibility of integrating inventories, SciNote inventories with external, with other piece of software. They're mentioning the example of a purchasing software. So I know that we have many customers who leverage our
Yeah.
inventories and they connect them to different software. So maybe you can tell us more about it.
Yeah, of course. That's actually a great question. So before I answer that question, I do want to highlight that we already have an integration with Quartzy. So there is a purchasing lab inventory management software called Quartzy that helps you order new items, keep track of the catalog number of vendors, etc. So we have a direct integration with Quartzy. So you can set up your Quartzy inventory, connect it to your SciNote inventory, so it automatically populates your data from Quartzy into SciNote. And from SciNote, you can update how much is being consumed, and all that information is updated in SciNote. If you want SciNote to update this information in Quartzy, you can do that using our API. For the initial integration, the information update is just one directional. So whatever is in Quartzy and whatever is updated in Quartzy is updated in SciNote. What's updated in SciNote is not reflected back in Quartzy for now, but in later integrations, we will have a bi-directional data flow. And when it comes to integrating with procurement software, it's all done through API. So if you have a procurement software with API access, you can take SciNote's API and whatever data you want from SciNote to go into your procurement software, you can use the relevant endpoints, set up the data flow, and push that data into your procurement software. Our Quartzy integration is powered using our API and Quartzy's API.
Great, thank you. We have another question. And here, maybe I will read it to you. In the extraction protocol, can you specify the volume of a sample, so not of a material, of a sample used, and would it update? And can you have a notice if a sample is finished?
Yeah, of course. In fact, let's do just that. So let me actually first go to our inventories. Let's say we're using our genomic DNA here. I didn't set the stock, but I'll do that now. So let's say we have 100, set up our low stock reminder via 20.
Yeah, this is basically the reminder that will help us receive the notification for when it's finished.
So now we'll go back to, I believe it was the extraction protocol, correct?
Yeah.
So under assigned items, this is our sample inventory. So here you can input how much is being consumed volumetrically, so how much volume is being consumed. So let's say we consume 90. It automatically updates. If we go back to the inventory, we would see that there's only 10 microliters left. This has also triggered the low stock warning. So we see the icon here. We see the alert here, only 10 left. And just to complete the picture, if we go to the inventory, right here, got the warning, alert right here. And I believe the question is what happens if it was finished, right, Eva? So let's go ahead and update how much was consumed. Let me also make sure we have the location assigned because I would like to show this in the location section as well. So let's say we actually consumed all of it. So we get a red alert because there's none left. There is no stock left under this warning. And then even if we went to our freezer and box where this item is located, we'll see that there is no stock left. So now we can pull this out and bin it and then free up this space to be used by a new vial, new sample, whatever it is that you want to put in the box, you can use that space for.
Yeah.
And I hope that answered the question.
And I would like to add that you can also get this notification that the sample is finished via email if you prefer, so that you the chances that you don't miss that information are higher, of course.
Yeah,
So we
otherwise
recommend
someone
that.
has to keep logging into SciNote
Mhm.
and checking this, or whoever is performing the protocol has to notify the purchasing person. So ideally, the purchasing person or whoever is responsible for managing your lab would have a SciNote account. They would enable reminders for low stock as well as expiration dates, and then be proactive rather than reactive when it comes to addressing things like ordering new supplies,
Yeah.
restocking reagents, samples, etc.
Exactly. All right, we don't have any other question for today.
And we are getting close to
Exactly.
the time. Maybe I'll mention just one last thing that I've seen actually with a recent customer of mine. What they're doing is they're tracking the calibration information for their instruments in SciNote, but they're actually also tracking the calibration procedures in SciNote. So they're using the project experiment task structure here. They actually went a step further and created a new team for instrument management. And in there, they created a project and for experiment task for each instrument. And they're putting in the calibration protocols. Any output from the calibrations are being uploaded as attachments to those protocols. And they're also signing off on it because sometimes you need a QA person to review the calibration and sign off on it. And even if you don't, you're signing off on it yourself, authenticating that the calibration was done and the data remains locked. There's more integrity, more compliance, etc. And if there's ever an audit and you need to prove that these instruments were calibrated in the right time frame, you can just select this project and generate a whole report. And the report will compile all of this data for you. You just share the report with whoever's auditing you, and all the data should be there for them to review.
That's great. It sounds like it's saving a lot of time.
Yeah, it can save a lot of time. And more importantly, it keeps you compliant. It helps you answer any questions that come from an auditor. And in SciNote, since all of this is captured digitally with a timestamp, date stamp, audit trail, there's no way to manipulate the data. Data integrity is at 100% here.
Yeah. Well, thank you, Arun.
Of course.
And thank you everyone for attending today. As I said, we will send you the recording, but if you have some doubts after any questions come up after this webinar, feel free to email myself, Arun, or your customer success manager, and we will answer. See you next time.
Thank you, everyone.